Okay, so let's get started with the zeros of the polynomial. So first off, we need to go over how to do synthetic division. I'm sure you've seen it excuse me, previously in your math life, but I'm going to start here with an example. So our example is 2x cubed minus 13x squared. Oh, sorry, I can't quit coughing. Plus 16x minus 5, and we're going to divide that by x minus 5. Okay, so here are the steps for doing synthetic division. First, you got to set up your little situation. So you make this little backwards L, leave some space, and a long line across. Then what we do is we use only the coefficients. Okay, and if we're missing one, we have to stick in a 0 to replace those missing coefficients, but we're not missing any, so there's 2x cubed minus 13x squares, 16x's, and the minus 5 is the constant. Now, we have to put our divisor in this little tray here, and the way that we do that is we set the divisor equal to 0 and solve it, and so 5 is what needs to go here in this little spot. Now when you're doing synthetic division, the first thing you have to do is you have to kind of prime the pump. In other words, you have to bring down this first value. So we've got that going. And now what we do is we get to multiply on the diagonal and then place the number and add down. So 5 times 2 is 10. Negative 13 plus 10 is negative 3. 5 times negative 3 is negative 15. 16 minus 15 is 1. 5 times 1 is 5. And we're left with 0. Now, let's break this down. The 0 here is the remainder. And here, because the remainder is 0, we know that these divide evenly. The remaining piece here, these three numbers that are left in this case, is the quotient. And if we were so inclined, we could say that is equal to 2x squared minus 3x plus 1. Now, this makes sense because we have basically, from our original, we have divided out a factor of x. So our quotient is going to be 1 degree lower. Okay. So let's do another example here just to make sure. I'm hoping you've seen this before, but if not, you're going to get plenty of practice by the time we get done here. So our next example is going to be 6x cubed minus 19x squared plus 19x minus 8. And I'm going to divide that by 3x minus 2. So let's get ourselves all set up here. Putting the coefficients only of the dividend. So 6, negative 19. 19, negative 8. And then we also need to put our number in here, and that means that we're going to take the divisor, set it equal to 0, and solve it. So x is equal to 2/3. We also have to start this party by bringing down that 6, and so now we're going to multiply on the diagonals. 2/3 times 6 is equal to 4. Negative 19 plus 4 is negative 15. 2/3 times negative 15 is negative 10. 19 minus 10 is 9. 2/3 times 9 is 6. 8 minus negative 8 plus 6 is negative 2. So here we have a remainder. All right, and let's just write our quotient. Our quotient is equal to 6x to the, we take 1 power of x away. This is our constant. This is our x. This is our x squared, and this is our remainder. So we have 6x squared minus 15x plus 9. And then to write the remainder, remember it is the remainder, so negative 2 over the divisor, 3x minus 2. Okay, now we're not going to get in the weeds too deep with this. We're going to use this as a tool, synthetic division as a tool, checking for remainders and such. Let's give you your first do. So here I just want you to do this division. We've got 9x squared plus 22x plus 10. We'll divide that by x plus 2. Okay, so I'm just going to show the setup real quick and give you a couple of minutes to do this problem. Okay, let's finish this up here. Hopefully you're done. 9, 22, 10. I'm going to go ahead and bring down my 9 real quick. Here, this is x plus 2 equals 0, so x is equal to negative 2. We're going to put in here. And now we're going to multiply on the diagonals and add down. So negative 2 times 9 is negative 18. 22 minus 18 is 4. Negative 2 times 4 is negative 8. 10 minus 8 is 2. So to write the quotient here, now we started off with x squared, so this is constant term, this is just x, so the quotient is going to be 9x plus 4 plus, because it's a positive remainder, up here it was a negative remainder, so plus, and in this case 2 over x plus 2. Okay, let's move on from here. So we're going to knock out a few theorems that are going to allow us to factor large polynomials that we wouldn't know how to regularly do. So let's start off with the first theorem, and the first one is the remainder theorem. So we suppose f is a polynomial function. If f of x is divided by x minus c, then the remainder of that division is f evaluated at c. So basically in practice, when you're using synthetic division, the remainder is equal to evaluating the function at that particular x value. Let's look at an example here. So let me see here. Let's find the remainder. I forgot I already wrote that down. So find the remainder when f of x is equal to x cubed minus 5x squared minus 6. So find the remainder when this is divided by, we're going to do a couple of them. The first one would be x minus 2. Okay, so what we're going to do in practice here is we're going to use synthetic division. Because this is very, very quick when you do it with synthetic division. So here we go. We're going to set up our synthetic division. Now here we're going to use just the coefficients. So the coefficients are 1x cubed, negative 5x squared, and watch this out here. There are 0 x's. So I got to put in that placeholder for 0 x's and then minus 6. Okay. I'm going to go ahead and bring that 1 down here. And now what we're going to do is figure out this. X minus 2 equals 0, so x is equal to 2. So that's the number we're going to put in here. And we're going to do it. 2 times 1 is 2. Negative 5 plus 2 is negative 3. 2 times negative 3 is negative 6. 0 minus 6 is negative 6. 2 times negative 6 is negative 12. Negative 6 minus 12 is negative 18. So now we can say that f of 2 is equal to negative 18. In other words, when we evaluate this function, and we could plug in 2 here, and I'll show you just real quick over here on the side, f of 2 is equal to 2 cubed minus 5 times 2 squared minus 6, so that's 8, minus 5 times 4 is 20, minus 6 is equal to negative 18. Okay, so it does actually work, and this was quicker and easier. You don't have to deal with all of those powers. So this is the benefit of doing this using synthetic division. Let's do another one here. Let's check out x plus 4. So same. And we have 1, negative 5, our 0 for our placeholder, and our negative 6, because those were our coefficients of our polynomial. And when we do this guy, we have x plus 4 equals 0, x equals negative 4. Now I always work that out because, as you noticed on one of the examples with the synthetic division, it was actually a fraction. So you can't just say it's the opposite of the constant, because sometimes you have to divide it. So I just make it a practice to just do that math. It's really simple math, and so I just do it that way. Okay, negative 4 times 1 is negative 4. Negative 5 minus 4 is negative 9. Negative 4 times negative 9 is positive 36. 36 times negative 4 is negative, let's see, 4, carry the 2, negative 144. Negative 4 times 144, let's see, is 6. Carry the 1, 7, carry the 1, 576 positive, so our answer is 570. And as long as I did not make an arithmetic mistake, which I don't think that I did, then I'm going to agree with that number. I didn't want to pull out my calculator for 4 times 144, but 16, carry 1, 17, carry 1, 5. Yeah, I think I'm good. Okay. Let's keep on going. The next theorem that we have is something called the factor theorem. And what the factor theorem says is, suppose that f is a polynomial function, and if f of x is divided by x minus c and the remainder is 0, then x minus c is a factor of f of x. Now this is extremely powerful. This is the crux of this whole end of this chapter, is the idea that we can take something that we couldn't readily factor, and we can factor it using another method, which is using this synthetic division and looking for zero remainders. So let's look at an example here. So determine if the following are factors of this function, f of x is equal to x cubed minus 2x squared plus 3x plus 6. And we'll do x minus 2. So again, we're just going to do our synthetic division here. We have a 1, a negative 2, a 3, a positive 6. Oh, I'm sorry, I just got crazy there. I really do like my color coordination. 1, negative 2, 3, and 6. We need to solve this guy. X minus 2 equals 0, x equals 2. Bring our first number down, and then we get to multiply on the diagonals and add down. 2 times 0 is 0, 3, 2 times 3 is 6, 12. So here we got a remainder of 12, and that means that x minus 2 is not a factor of f of x. And it's because we got this remainder here. Let's try another one here. Let's see about x plus 1 and see how that does. Still the same. 1, negative 2, 3, and 6. In this case, we have x plus 1 equals 0, so x is equal to negative 1. Bringing down here, so we have negative 1 gives us negative 3, gives us positive 3, gives us 6, gives us negative 6, gives us 0. That's what we're looking for, and so we can now say that x plus 1 is a factor of f of x. So you see, we're just going to do this really simple arithmetic method. Sorry, I got something that's been in my eye all day. Arithmetic method to just start looking for these zeros for remainders. So that brings us to the last theorem for now. I think I have one more theorem in general for today, but the last theorem for now, and this is the rational root theorem. Remember, roots are the same things as zeros, the same things as solutions, are the same things as factors, are the same things as x-intercepts. So this is all the same thing that you really are familiar with what I'm talking about. But we call it a whole bunch of different names. So here's the technical. Let f be a polynomial of degree 1 or higher of this form. And this form is basically the same as me saying x cubed plus x squared plus x plus 1. Just meaning that we go from the highest power of x down to the lowest, and that the coefficients can be different numbers even if they turn out to be the same value. Okay, so if this is our equation where every coefficient is a product of the real number, so let me make sure early here that you understand that this is equal to the real numbers. Well, that is not really the real numbers. This is the integers. My bad. And that is plus or minus whole numbers, right? Positive or negative whole numbers. This also says a sub n cannot be 0 and a sub 0 cannot be 0. In other words, there has to be a leading coefficient and there has to be a constant. A sub n is called the leading coefficient because it is the coefficient of the highest power of the variable. Okay, so if P over Q in lowest terms is a root of 0 of f, then P must be a factor of A naught and Q must be a factor of A sub n. Now this is all very math gobbledygook. That doesn't get us to in practice, and so let's get to the in practice part. In practice, you find the factors of the constant and the factors of the leading coefficient, and you put them together and you list out all those possible combinations. Okay, so this theorem, equally as strong as the previous one, produces us an exact list of the possible real numbers, the possible integers that, well, not necessarily integers, but real numbers because they could be fractions, right? But gives you a definitive list from an infinite list down to a definitive list of numbers to check to see so that you can factor the equation. Okay, so it if it is not on the list, if you have a list and you think you want to try a number that's not on the list, don't waste your time. Okay, that's the really important part here, is that this really gives you the list of potential zeros. There will not be any beyond this option here. So let's see, how does this work? So we're going to use the rational root theorem to produce a list of possible zeros. So let's start off with our first example here. We're not going to do anything beyond finding a list of the possible zeros. So 6x cubed minus x squared plus x minus 12. Okay, and the way that the rational root theorem works, and this is how I always denote it, rational root theorem, it is the factors of the last, so we need factors of 12 over the factors of 6. Now, what are the numbers that are factors of 12? Let's remember what a factor means. It means it's a number that goes into it evenly. So 1 goes into 12, 2 goes into 12, 3 goes into 12, 4 goes into 12, 5 does not go into 12, 6 goes into 12, 7 no, 8 no, 9 no, 10 no, 11 no, 12 goes into 12. Okay. Same thing here with the 6. 1 goes, 2 goes, 3 goes, and 6 goes. Now, we're going to take all these numbers and we're going to comprise a comprehensive list of all the options. Now, when you start making a big long list here, I want you to remember that it is a finite list versus an infinite list. Okay, so this is just a finite number. So even if it's 30 numbers for you to check, that's better than 3,030,000 numbers and still not checking them all. Okay, all right. So, because a lot of times students get frustrated, this is such a long list, and I'm like, dude, it's better than no list at all. Okay, so this is how we're going to do it. So the way I do it very methodically. I take every number in the numerator and I set it with every number in the denominator. Let me show you how it's going to go. And we also get plus or minus all of these values. So I'm going to write a plus or minus in front. So I have 1 over 1, 1 over 2, 1 over 3, 1 over 6. So I'm done with the 1. And then I'm going to roll through every single one of them. And then I'm going to clean up my list at the end. Don't start skipping. Don't start doing your math while you're going, because if you miss one, I guarantee that's going to be the one number that you needed to know. Okay, so just be patient with yourself. 1 over 6. So I've got 2 over 1, 2 over 2, 2 over 3, 2 over 6. 3 over 1, 3 over 2, 3 over 3, 3 over 6. Notice we got lots of repeats, but just go ahead and do it. 4 over 1, 4 over 2, 4 over 3, 4 over 6, 6 over 1, 6 over 2, 6 over 3, 6 over 6, 12 over 1, 12 over 2, 12 over 3, 12 over 6. Okay, and then I go through here and I just kind of like clean them up. So let's get our plus or minus. We got 1, 1/2, 1/3, 1/6. 2, 2/2 is 1. We need 2/3. 2/6 is 1/3. 3, we need 3/2, don't have that yet. 3/3 is 1, got that. 3/6 is 1/2, got that. We need 4. 4/2 is 2, got that, but we don't have 4/3. Write that down. 4/6 is 2/3, and we got that. So then we need 6. 6/2 is 3. 6/3 is 2. 6 over 6 is 1, and 12. So from an infinite number of possibilities down to these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 options is pretty awesome. Another thing I typically do before I get started is I like to also put them in order. So I would put them in order as well. So what do we have? 1/6, 1/3, 1/2. What else do we got? 2/3, 1, 4/3, 2, 3/2, 3, 4, 6, and 12. It's just nice. You don't have to, certainly, but it'll help you kind of keep your business in order. All right, let's do another one real quick. And I'll give you one to do. F of x is equal to 12x to the 4th plus 3x cubed plus 6. Okay, so here we're going to do our rational root theorem. And here we're going to have 6 factors of 6 over the factors of 12. The factors of 6 are 1, 2, 3, and 6. Of course, we just did this, but notice I wanted to make sure you saw it was different. 1, 2, 3, 4, 6, and 12. So let's get the list. I probably will not put this list in in numerical order because we're not really doing anything with the list. We're just writing it out, just practicing. So here we have 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, 1 over 12, 2 over 1, 2 over 2, 2 over 3, 2 over 4, 2 over 6, 2 over 12, 3 over 1, 3 over 2, 3 over 3, 3 over 4, 3 over 6, 3 over 12, and 6 over 1, 6 over 2, 6 over 3, 6 over 4, 6 over 6, and 6 over 12. So let's write this out after we've cleaned it up. So plus or minus, we got 1, 1/2, 1/3, 1/4, 1/6, 1/12. Then we got 2, 2/3, 2/4 is 1/2, 2/6 is 1/3, 2/12 is 1/6. So we're good with that. 3, we need that 3/2. We don't have 3/4. We need that one. 3/6 is 1/2. 3/12 is 1/4. Then we need 6. 6/2. We got 6/3. That's it. No comma necessary. Okay, so let's give you one to do. And let's see here. We'll do 5x cubed. (5x cubed) minus 7x squared plus x minus 20. And I'll give you about a minute and about a minute and a half. Okay, let's see what we got here. We've got plus or minus 1 over 1, 1 over 5, 2 over 1, 2 over 5, 4 over 1, 4 over 5, 5 over 1, 5 over 5, 10 over 1, 10 over 5, 20 over 1, 20 over 5. Okay, awesome. So let's get this final thing here. We have 1, 1/5, 2, 2/5, 4, 4/5, 5, 10, and 20. All right. Yay! Okay. Now we did all that to bring us to this point, which is putting it all together and factoring something we didn't already know how to factor. So let's take a look here. So let's start off with this problem. F of x is equal to 3x cubed plus 4x squared minus 5x minus 2. Now I am going to suggest that you always take a look, always, and see if you can employ any other factoring technique that you already know, right? Look to see if it's the difference of squares in there. Look to see if you've got the sum or the difference in cubes in there. Look to see if you can factor it using the AC method. And most importantly, because this is already 4 pieces, I would look to see if you can split it in half and factor it. Now you can see here that we cannot factor this guy by splitting it in half. It has got 4 pieces, so we can't use the AC method on it. It is not the differences in squares. I think we've exhausted all of the tricks that we currently know so far. So what we're going to do is we're going to use the rational root theorem, produce a list of possible zeros, use synthetic division to get it down to the point that we can finally use the quadratic formula. Because remember, we could use the quadratic formula, say, if this wasn't to the power of 3. Now there is a formula like the quadratic formula for cubic equations, and there's even one for equations to the 4th and to the 5th power, but they are huge, huge, huge equations. Like you can't even imagine how tremendous. In fact, if you want to look one up and take a look and see what that formula for finding the zeros of a cubic, I encourage you to do so because it's very interesting and it will make you just love this method even more. But anyhow, okay, so let's get started. The first things first is I'm going to find my list of possibilities using my rational root theorem. That is going to be the factors of 2 over the factors of 3, which is going to give me plus or minus. And let me, because we're still new here, let me just go ahead and write them all out. Our factors of 2 are 1 and 2, and our factors of 3 are 1 and 3. So this is going to give us plus or minus 1 over 1, 2 over 1, 1 over 3, and 2 over 3. And I'm sorry I did that in kind of a weird way. My brain just short-circuited it. That's how I did it. But anyhow, this is our list, and I'm going to make it kind of pretty and put it in order here. It's going to be plus or minus, so the positives and the negatives here of 1/3, 2/3, 1, and 2. And if you were so inclined, you could write it all out like this: -2, -1, -2/3, -1/3, 1/3, 2/3, 1, and 2. And that would also give you, the list without, and you could see every one. I don't hate writing out the list because sometimes you might have to try a few to find the right answer. And so if you write the entire list, you can mark them off as you've tried them, so you don't go back and try the same thing you've already tried before. Okay, so let's just get started here. So the first things first is you determine the list of possible zeros using the rational root theorem, which I just did. Next, we're going to start doing synthetic division. And here we have 3, 4, -5, -2. And in this case, it doesn't matter which one I choose. Let's see, let me choose -1. Okay. And I'm going to bring down my first number here. And remember what the name of the game is. We're just looking for that zero remainder. So -1 times 3 is -3. 4 minus 3 is 1. -1 times 1 is -1. -5 minus 1, -6. -1, -6, +6, not a 0, right? So we're going to come up here and we're going to take -1 off the list because it didn't work. Now, my suggestion is you just, so you're not using tons and tons of paper, you can just do this. At least this is what I'm going to do. And let's try another one. If we were in class, I would ask you to give me a number, but since we're not in class, I'm going to be evil and I'm going to do a fraction. Everyone's always scared of doing this with fractions, so let's just keep on doing it with fractions, okay? All right, here we go. -1/3 times 3 is just -1. 4 minus 1 is 3. -1/3 times 3 again is -1. -5 minus 1 is -6. -1/3 times 6 is +2. -2 plus 2 is 0. I'm so happy. This is 1. Yay! Now, how many factors will we have? We will have 3 factors. However, you could continue to do this. You could continue to use synthetic division, but once you get down to a quadratic equation, meaning you have A, B, and C, and notice that we're down, our quotient now is quadratic with our A, our B, and our C, with our remainder being a 0. So we're absolutely happy here. We can use quadratic formula, and I expect you to do so. Please lean into it. it doesn't prove anything for you to not use quadratic formulas. So at this point, now that we have this here, we're going to use quadratic formula. And in fact, I am going to divide all this by 3, and my A is going to be 1, my B is going to be 1, and my C is going to be -2, because we're able to divide all of these guys by 3 and just make the math easier. That's the only reason why I did it. You don't necessarily have to do that, but if you can see places where you can make your math easier, you should jump on there. So x is equal to -b, so -1 plus or minus the square root of b squared, so 1 squared minus 4 times 1 times -2 all over 2 times 1, and then let's just clean this up. So we've got -1 plus or minus 1 plus 8 is 9, so that gives us 3 over 2. So that's going to be -1 plus 3 over 2 and -1 minus 3 over 2. So this gives us 2 over 2, which is 1. This gives us -4 over 2, which is -2. Now, we've gone the one direction where we in 5.1, in section 5.1, I gave you the zeros and we built the polynomials. Now we're not going to build the polynomials, meaning we're not going to multiply them back out, but we're going to write this in completely factored form. So let me just write out what our zeros are real quick. So our zeros were 1/3. That's one of them. We expect 3. We got 1 from our synthetic division, and we got 2 of them from our quadratic formula. So our zeros are -1/3, 1, and -2. And to write it out as factors, which is what I'm looking for, we're going to say f of x is equal to, and we use this trick that we use in chapter 5, which is how we can take a 0 and write it as a factor. And so we're going to have x minus a -1/3 times x minus 1 times x minus a -2. Okay, so this is in factored form. There's an alternative. If you don't like the fractions, you can clean up that one little factor by multiplying it through by 3. And so this is also the same as 3x plus 1 times x minus 1 times x plus 2. We want to give our solution in factored form, and this is in factored form. Okay. Lots of steps. None of the steps are particularly, really, really hard each step, but there are lots of steps. Let's do another one. So the last question I asked you to factor it, but here I want to ask you to find the solutions. I could also ask for the roots of this equation. 2x to the 4th minus x cubed minus 5x squared plus 2x plus 2 equals 0. Okay, and remember that roots and zeros and solutions and x-intercepts and factors, they all mean the same kind of thing. And here we actually have something to the 4th power. So that means we're going to have 4 solutions. That also means that we will have to do synthetic division twice before we can use the quadratic formula. I'm even going to write that there. Because of the 4th power. We will have to find 2 of the roots using synthetic division. Before the quadratic formula. Okay? All right. So first things first, let's do our rational root. And here we're doing the factors of 2 over the factors of 2. All right, so that's 1 and 2 over 1 and 2. That's going to be plus or minus 1 over 1, 1 over 2, 2 over 1, 2 over 2. Well, at least we've got a short list, right? So plus or minus, and I'm going to go ahead and put this in order, 1/2, 1, and 2, and I think I'll even put it so that I can mark them off. So I'll have -2, -1, -1/2, 1/2, 1, and 2. Okay, excellent. So we've made our list. Now we're going to set up our synthetic division here. Remember, I told you we're going to have to do it twice. So here comes our first one, 2, -1, -5, 2, and 2. And here, let's try 1. One times 2 is 2, -1 plus 2 is what? 1 times 1 is 1, -5 plus 1 is -4. 1 times -4 is -4. 2 minus 4 is -2. 1 times -2 is -2. 0. Awesome. So -1 is one of them. I'm going to just write over here. I'm going to get me a little list of what my zeros are over here. So far, 1 is one of the zeros. Now, you can go back to the original and try it again with other numbers on the list, or we can pick up from where we are and we can just do the division with what is left, because we have divided out an entire x minus 1 out of that problem now, and what we're left with is basically a brand new problem. Okay, so it is a good practice to try the number that you just got again, because a lot of times, as you know from graphing polynomials, a lot of times the same solution can happen more than once, right? We could have an x plus 1, that's to the third power. That means -1 is the answer 3 times over. So it's always good to try one that you just got over again. So let's just try 1 again. So I'm just going to try this out and see. It may work, it may not work, and it certainly isn't very time consuming, so you're not wasting a whole lot of time here. So 1 times 2 is 2, 1 plus 2 is 3, 1 times 3 is 3, -4 plus 3 is -1, 1 times -1 is -1, and this is not 0. Okay, so we know we can mark the -1 off the list because it's not going to work. And 1 has already worked for us. Okay, so we tried it, it didn't work. I'm just going to erase this. And let's try another one, and because of the magic of TV and the fact that I've already worked this problem, I'm going to choose a number that is going to work, which is -1/2. I'm seeing how long we've been going at this, so I've got much more to still do, so we got to get moving here. So -1/2 times 2 is -1, 1 minus 1 is 0. 0, negative 4, negative 1/2 of 4 is a positive 2. We've done it. We've got our other 0, which is negative 1/2, and we're left with 2 of them. Now at this point, we can either use quadratic. So we have A is equal to 2, B is equal to 0, C is equal to negative 4. You could use quadratic here. But you don't have to. And so I'm going to not solve it like that. I'm going to take this information and we're going to write this as 2. We're going to write it as the quotient, 2x squared minus 4. Now, if I wanted to factor this, you know, and we're actually finding solutions here, so I'm going to set it equal to 0. I'm going to do this in the factoring way, though. Okay, so I'm going to factor out a 2, and that leaves me with an x squared minus 2 is equal to 0. And I don't know if I've shown you this yet, and if I have, I'm going to show it to you again. Anything can be the difference in squares as long as it is something squared minus a solid constant number. It doesn't have to be a squared number because we have square roots, right? And so this actually factors as x minus the square root of 2 and x plus the square root of 2. And now since we're actually solving this, this is x minus square root of 2 equals 0, x plus square root of 2 equals 0, so x is equal to the square root of 2 and x is equal to the negative square root of 2. As I said when we talked about factoring and everything, using the square root property is dangerous. A lot of times students lose half of their points because they missed half of the answers. So do be careful. So our zeros are 1, negative 1/2, square root of 2, and negative square root of 2. I didn't ask for this to be in factored form. I just asked to find the solutions. We could write it in factored form if we wanted. I'll just write it real quick. It's been a bit since I assigned your homework, so I can't 100% remember what your homework really wanted you to do. Probably a combination of both. Okay, and this guy right here can be rewritten as 2x plus 1 also if you'd want it that way. Okay, awesome. Let's do another one. Actually, I think I have, nope, I have another one. My notes are kind of messy. I really need to spend some time and clean them up. Okay, here's my next example. Sorry. F of x is equal to 2x to the 4th plus x squared minus 1. Now, hold on, let me grab a little sip of my drink. Now, I told you back earlier in this lecture that you don't always have to factor using this method, and you want to always look to see if you can factor something quicker, something that you're more familiar with, something that's not quite as tedious and prone to error. As you can imagine, doing all this synthetic division could be problematic if your arithmetic is a little bit lax or whatever. If you make one little sign error, you can think that a number doesn't work when it actually did. So there's reasons for you not always just landing on that. But If we take a look at this particular problem here, it's got 3 pieces, and I'm always taking a side eye at any polynomial that's in this kind of form where the leading power is even and the middle power is half of that, right? You can kind of see the pattern here. X squared raised to the second power is x to the fourth. Like another situation where I would like eyeball this, if this would say 2x to the sixth plus x cubed minus 1, I'd go, oh, look at that, 6 and 3. I think I might be able to do this. So I'm taking a look at this, and I can immediately see that I can factor this. I know I can factor this. So I'm going to factor this kind of using the AC method, and if you didn't see it, I'm going to like rewrite it over here, and I'm just going to change the variable to y. I'm going to say y is equal to an x squared. So I've just rewritten the problem like this. Now this is a problem you've been doing for a really long time, certainly since the beginning of this class. So let's go ahead and do it. 2 times -1 is -2. So I'm going to need to rewrite this using the AC method. The numbers I'm going to want to write in here are positive 2y and a negative 1y. And then I'm just going to drop the other 2 pieces down. Again, we've factored like this. And if you're still struggling with factoring, you need to holler at me because it doesn't get any better. And so you can see that this factors as 2y minus 1, y plus 1. So over here I can easily say that this factors as 2x squared minus 1, x squared plus 1. Now, what the directions were, which I didn't write down, but they are to factor completely. And you know that this guy thus far is prime, so this one doesn't factor anymore as it stands right now. But this other one does. And there's a couple of different ways we could do it, but I'm going to do it as the difference in squares. And this is going to be the square root of 2x squared minus 1 squared. So this is going to be the square root of 2x minus 1 square root of 2x plus 1. Now, because of the way that we're sometimes a little bit lazy with the way that we write our arithmetic, our algebra and stuff, you want to write it as x square roots of 2 minus 1 times x square roots of 2 plus 1. We write that square root, that radical at the end, so that there is no ambiguity on whether the variable is under the radical or outside of the radical. All right, so just want to make sure that you understand that. So this guy factored completely is x square root of 2 minus 1, x square root of 2 plus 1, and x squared plus 1. So I did this problem for you though, so you will, even if we're in a section that the homework is directed towards teaching you how to do this process, that it's important for you to keep your eyes open to things you already know how to do and apply those. Okay, now we're an hour in, and so I had a you do for you to do, but I've got probably about 10 more minutes of stuff to do. So I'm going to give you the you do, and I'm not going to give you time to do it. So I am going to want you to please pause and try this problem, okay? So here goes the problem. F of x is equal to 3x cubed plus 4x squared minus 7x plus 2. In fact, I'm going to move to the next page because I won't have enough time to do this. So pause. Okay, so hopefully you paused and you're now back. And we're going to use our rational root theorem first to get our list of possibilities here. That's going to be plus or minus, and I'm going to do it this way. Actually, I'm just going to put them in order. I have -2, -1, -2/3, -1/3, and then 1/3, 2/3, -1, and -2. So there's our list. Three, 4, -7, and 2. And let's see here, because of the magic and because I've already worked the problem, I'm going to jump right to that answer here, and 2/3 is the number that's going to be the winning ticket. Ugh, thought I hit that. Bring down the 3, and here we go. 2/3 times 3 is 2. 4 plus 2 is 6. 2/3 times 6 is 4. -7 plus 4 is -3. 2/3 times -3 is -2. And we get our 0. Yay. This also is a situation here where with our A and our B and our C. So I'm just going to, for the funsies, I'm going to write this as 3x squared plus 6x minus 3 equals 0. And I'm going to see if this is factorable by taking out the 3 here. So I've got x squared plus 2x minus 1 equals 0. This does not factor, as you can see, because the factors of -1 that give +2, this does not factor, so we'll have to use the quadratic formula. Our A is equal to 1, our B is equal to 2, our C is equal to -1. So x is equal to -b plus or minus the square root of our B squared minus 4 times our A and times our C, and all of that is over 2 times our A. Let's get this, -2 plus or minus the square root of 4 plus 4 is 8 over 2. Now you can't leave it to me like that. This is a -1 plus or minus the square root of 2, but I think I got to show you how I got that. Sorry. Okay, so this is -2 over 2 plus or minus the square root of 8 over 2. The square root of 8 is 2 square roots of 2, so this gives us -1 plus or minus square root of 2, because the square root of 8 is equal to 2 roots of 2. Okay, and so I think I want you to write this out factored. So our factors are x minus 2/3, x minus a -1 plus the square root of 2, x minus a -1 minus the square root of 2. And then that could be cleaned up a little bit more if you were so inclined and you didn't like the fractions, but honestly, these numbers aren't very pretty, so you might as well go with the fractions. Okay. All right. Now I have one last thing to talk about, and it's called the intermediate value theorem. Okay, and so the intermediate value theorem goes like this. Let f denote a polynomial function if a is less than b, and if f of a and f of b are of opposite signs, then there's at least one real zero of f on the interval between a and b. Now let me draw a picture real quick, because the picture tells the whole story here. So say we have got a graph like this. Actually, let me make that better. Say we've got a graph like this, okay? And here, call this point A. Here, we'll call this point B. Now, you can see that in between A and B, the graph crosses the x-axis somewhere. And remember, where the graph crosses the x-axis is a 0, because x-intercepts are zeros. X-intercepts are solutions, they're roots, they're factors, all of those things. Okay, so in practice, if you evaluate the function at both ends of the interval you're given and the signs are opposite side, one's positive, one's negative, one's positive. If the signs are opposite, then you know that the graph crosses 0 somewhere in between those two numbers, and that's what we're going to work with here. And so determine if there's a 0 in this given interval, and here we go. Here's our function, 2x to the 4th plus x squared minus 1, and our interval is between 0 and 1. So what we want to do is we want to find f of 0 and f of 1. Now, because these are easy numbers, I'm not going to use synthetic division here. I'm just going to plug them in real quick in my brain. So f of 0 is equal to -1, and f of 1 is 2, plus 1 is 3, minus 1 is 2. Those are opposite signs, so therefore, yes, a 0 is in this interval. At least one. It could be multiple, but we can say for sure, because the sign changes, we can say for sure there's at least one. How about 1 and 3? Let's check that out. So we know f of 1, we just figured that out. F of 1 is equal to 2. What's f of 3? Well, f of 3 is a little bit harder to do. I'll just do it with some synthetic division real quick. I got a 3 here, and we've got a 2 and a 0 x cubes and a 1 and a 0 x, so 2x to the 4th, 0x cubes, 1x squared, 0x's minus 1. Just going to knock it out here real quick. 3 times 2 is 6, 6, 18, 19, and 3, 9, 7, carry the 2, 57. 57 times 3 is 21, 15, 16, 17, 171, so that's like 170. So you can't say that there isn't one, but you can't say that there is. So it is not clear there is a 0. In this interval. Okay, we're almost done. One more example and a you do. Here we go. Y'all are doing great. One more example and a you do. So let's see. Let's show. Here is a root in the given interval. And let's have our function here. Our function is f of x is equal to 3x cubed minus 10x plus 9. And our interval is between -3 and -2. So let's check it out here. I'm going to use synthetic division here because it's just going to be easier. So for -3, I have 3x cubes, 0x squares, minus 10x's, and a 9. Don't forget your placeholder. In fact, I'm going to color it a different color. That's that placeholder because we don't have any x squares. Okay, I'm going to bring this down. Bring down this 3. -3 times 3 is -9. 0 minus 9 is -9. -3 times -9 is positive 27. -10 plus the 27 is 17. This is a negative big number. And we know this is going to be a negative number. Remember what we're doing. We don't care what the value is. We just need to know the sign. So I'm not going to get all caught in the weeds trying to figure out what that value is. Now I'm going to check with our -2. So if I've got -2 here, we have 3. We still have that placeholder of 0, -10, and 9. And we do this guy. Bringing down the 3, we have -6. -6 gives us positive 12, gives us 2, gives us -4. This one's easy enough to figure out. I'm going to say it's 5. That's a positive number. Therefore, we can say at least one root in the interval from -3 to -2. Okay, and finally, I have your last you do. So we want to determine if there's a 0. So determine if a 0 in the interval. Okay, let's see, our f of x is equal to 2x cubed minus 12x squared minus 2x plus 60. And I'm going to give you 2 of them to check. The first one is going to be -1 and 2. And the second one is going to be 4 and 7. Okay, I'm going to give you a couple minutes to finish this. This is our last problem. I'm going to suggest you probably don't need to do the synthetic division with this first interval because it may be easy enough for you to do the mental math on that arithmetic, but certainly for 4 and 7 it's going to require some synthetic division. In fact, I think I'm just going to tell you the yay or the nay here. Well, no, let's just do it. Okay, let's just do it. So here for this first guy, f of -1. When I stick in -1 here, I'm going to wind up with -2 minus 12, because the negative doesn't change that, plus 2 plus 60, and that is a positive number. And it doesn't matter what the number is. Remember, again, we're just looking for sign change. F of 2 here, so that's 8 times 2 is 16, minus 12 times 4 is 48. I'm just doing it because it's pretty easy. 2 times 2 is minus a 4 plus a 60. Looks like I'm going to have to do a little bit more work here. 48, 16 minus 4 is 12. 16 minus 4 is 12. 16 minus 48 is 12. So this is also a positive number. So not in this interval. Over here, I'm actually going to do the synthetic division real quick. For the 4, we've got 2, -12, -2, and 60. Bring down our 2. We have 8, -4, -16, -18. It's like 20 times 4 is 80, so -18 times 4 is going to be a negative number bigger than that, but I'll go ahead and figure it out. Let's see, 2, 3, -72 gives us -12. And then let's do the other one here. 7 goes into 2, -12, -2, 60. Bringing down the 2. Here we have 14 gives us 2. 14 gives us 12. 84, positive number. So here we can say yes, 0 in this interval. All right, y'all. We did it. Have a good day.